So the recording has just begun, and I just want to welcome you once again to the very last um, class for the week. This is week number 5, or in Spanish, I think it's cinco or something like that. And in French, it's cinq. So this is the 5th week, the last class in the 5th week, and I don't know. I just
And
feel
in Japanese, it's go.
oh, okay. I don't know, but I don't know if it's just me, but it felt like this week went so fast. I don't know when. First, it was, I mean, this week, I just can't believe it's Thursday already. Um, but yeah, a very swift week. I just felt like the days was marching on. Um, at any rate, this is our last installation, so let's make the most of it. So, yesterday was the powerhouse. I really enjoyed yesterday's class. We covered a lot. Um, we did some good things on yesterday, and today is gonna be the same. Remember, for today we have math. Then after that, for those who are taking the social studies Bgcse, stay back because we have social studies Bgcse classes after that, and then right after that is the RK. Right, so we end on a good note. All right, so let me share my screen so that we can begin. Okay, just like how we did yesterday, we're gonna alternate between easy questions and difficult questions, or I should say I should say between familiar and non-familiar. So some questions are pretty familiar. We see them time and time again. Other questions you'd be like, this is kind of unfamiliar. I don't really see this often. And so we're gonna alternate between familiar and unfamiliar questions. And so let's begin with a familiar type of question. Okay, so yesterday we dealt with this paragraph. Um, Today we're gonna be doing some geometry, so this should be familiar territory for us, and so let's consider it. So please draw in the image and draw in the questions and send the notes to me as we continue step by step. All right, so let's go. I wonder if we saved it. Okay, yeah, we did save it. Good. All right, good. All right, so let's consider this question. So number 11A, they want us to calculate the size of angle A, and they want us to calculate the size of angle B. Okay. The size of angle A is, anyone know? That's very straightforward.
55 degrees.
55 degrees, yes. So angle A equals 55 degrees. That's its size. Now the reason for that, I think someone's trying to enter. The reason for that is because if you look carefully, so the reason is that it is vertically opposite.
I learned that in math.
Okay, that's good. It's vertically
Like it's the
opposite.
opposite and adjacent angle.
Yeah, it's vertically opposite to A. Sorry, it's vertically opposite to 55. And when we say vertically opposite, this is what we mean. Um, Let me just show you. So two angles are said to be vertically opposite if the following holds. So let's say we have something like, say we have this line going like this. We have a next line going like that. Okay. And we say, let's say we have this angle here. And let's say we have another angle here. So let's call this one angle A and let's call this one angle B. What can we say about angle A and B?
They are They are opposite of each other and equal the same.
They are vertically opposite. So angle A and B are said to be vertically opposite when they appear like that. Let me allow these persons to come in. Okay, good. So we say that angle A and B are vertically opposite when it's like that. Let's say, for example, we have another one. So let's say we have angle C and angle D. Okay, what can we say about angle C and angle D?
Opposite of each other.
They're vertically opposite. Okay,
Vertically.
so again, angle C and angle D are vertically opposite, and angle A and angle B are vertically opposite. And vertically opposite angle, one property of vertically opposite angles is that they are equal to each other. So here we note. So here we note that angle A and B are vertically opposite angles, right? And angle what? C and D
E.
are vertically opposite. Uh, we also know that what should be mentioned, it should be mentioned that vertically opposite angles are equal to each other. Okay, so that means that angle A equals to angle B and angle C equals to angle D because they're vertically opposite. Okay, so just bear that in mind. So again, A and B are vertically opposite angles, C and D are vertically opposite angles, and we know that vertically opposite angles are equal to each other. And so if we were to go back on, can I move the slide? Let me know.
Yes, sir.
Okay, so if we were to go back on, okay, so here, so that means notice that A and 55 are vertically opposite angle, and so that means that A is 55. Okay.
What if?
Go ahead.
What if the 55 is on top?
You mean say here?
Mm-hmm.
If the 55 is on top, then we wouldn't use this idea. We would use the idea of the sum of angles at a point. Sorry, the sum of angles on a straight line add up to 180, and then we'll say 180 minus 55 would have been the answer. But because it's like this, then we use the vertically opposite angle.
And then how would we find the total degrees inside the angle?
What do you mean?
Like it's supposed to add up to 360, right? Or no?
No, no.
Or
Okay,
180 inside a
180.
triangle?
You mean okay? What number you talking about? What letter you talking about? We did B. We did A.
A, B, and C.
You mean this question?
Yeah, in this question.
Okay. It's not difficult because in fact let's do it. Let's figure out what B is. The biggest hint is that we have these two lines there. And what does the two line tell us?
That both sides are equal.
Yeah, the two line tells us that both sides are equal, but more than that, the two lines not only tell us that both sides are equal, but both angles are equal. Okay? So that is to say, if this is A, this is also what?
A. A.
Okay? And we know that A is 55. So since this is 55, this must also be 55.
55.
Okay? Now, in order to figure out what B is, we know that the sum of our interior angles in the triangle must add up to what?
180.
180.
180.
Good. So therefore B is going to be equal to 180 minus what? 55
55.
plus
Plus 2.
plus what? 55.
55.
And so it's going to be, so B is going to be equal to 180. What is 55 plus 55?
110.
110.
That's a 70.
So we can easily verify that. If we have 55 and 55, we know that 5 plus 5 is definitely 10. 0 down, the 1 up. 5 plus 5 is 10. Plus 1 is 11. So this is 110. So B is equal to 180 minus 110. So B is going to be equal to what?
70.
70 degrees. Okay, so copy that down for me and send it to me once you're done. Okay. All right, so make sure to send a picture of your work into me so I can see what you're doing. So it's important to know.
So Mr. B,
Go ahead.
if the interior, hold on, if the interior is 55, that means the exterior is 125, right? Because 55 from 180.
Yeah, you mean this one?
That's
Yeah, definitely.
and because that is opposite angle at the bottom, that's also 125, right?
Yeah, yes, sir. The vertically opposite. You can look at it like that. So this would be 55, 125, 55, 125. Add them all up. It's 100. It's 360.
So when it's on the outside, you subtract it from the angle on the inside?
Yeah, because yeah. So and I mean it wasn't like this in this question, but if we had say you know if we had say this line and we have A here and we're trying to figure out what sorry, we have A here and this is 125. So definitely A is going to be equal to 55 because 55 plus 50 plus 55 plus 125 is 180.
But we subtract, right?
75.
Yeah, so you would subtract, in order to figure what A is, you would subtract, you would say A is equal to 180 minus
I got it.
minus 125. And that's because angles at a point on a straight line add up to 180.
Okay, so what if the A is on the outside, like they want you to find the 125? Like, what if the 125 was A?
Yeah, the same thing would apply. So
Okay.
let's say this
So you
was
subtract. You
say this was
subtract
if this was A,
55 from it.
then this would be 55. And so A is going to be equal to 180. Sorry, that's supposed to be equal to. A is going to be equal to A equals 180 minus 55, which is going to be what? 125. So that's if they had given us like this. Okay,
Okay, thank you.
no problem. Okay, thank you, Raquel. Sending in the notes already. Thank you, Lakeisha Stubbs, Julia Raming, and Alicia. I still have other people who are not sending in the notes. Let's go, come on. Let's start the class right. Okay, so B is 3 points and to get A is 1 point. Alright, so yeah, so A is 55 and B is 70. Okay, so that's how we do something like that. So let's consider this one. So here we need to figure out what angle C is and what angle D is.
Yeah. Wouldn't C just be 62?
Why 62?
Wait, no, I lied. I'm
The angle on a point, right? On a straight line.
Yeah.
Never mind. We're doing everything else.
So here, what's the name of this shape?
Wait, a trapezoid?
Is it a rhombus?
I just wanted a general name for a four-sided figure. What do we call
Polygon?
I mean, no, I
A
mean,
rectangle?
say it
A
again.
rectangle?
I know y'all didn't just say rectangle just now. Please tell me I'm hearing things. Please tell me I did not say rectangle. It's a quadrilateral. Okay. And when we say quadrilateral, all that means is that it's a four-sided shape. Four-sided plane. Four-sided closed figure. Alright? Okay, so let's consider this. So we want to figure out what C is and we want to figure out what D is. So please draw this image. And once we finish the work, send it to me. So the first thing that we want to find out is what is C. And remember what we said. The rule is that angles on a straight line at a point add up to 180 degrees. So 62 plus C must equal to what?
180. 180.
Yes. So in order to figure what C is, what are we going to do?
C is equal to 180 minus 62.
Yeah, very good. So let's write that down. So C is going to be equal to, small c is going to be equal to 180 degrees minus 60 degrees. And that's going to be equal to what?
It's 118.
118, that's what you got?
Yes, sir.
Yeah.
So 180, 180 minus 62, 118, very good. All right. Now we have, and the reason, right, is because the sum, or we could say angles on a straight line
It's equal to 180.
at a point add up to 180 degrees. Okay, good. Next up we have D. And the idea of D is that if we have a quadrilateral, we know that the sum of all the angles in the quadrilateral is going to be equal to what?
360.
360 degrees. So all these together is going to be equal to 360 degrees. So D plus 73 plus 62 plus 115 gives us 360. So therefore D is going to be equal to 360 degrees minus, open bracket, what? 115?
115 plus 73
73.
plus 62.
Now let's do it in order. So 115, 62 plus 73. And that's going to be equal to 360 minus, let me add them, what we get.
250.
250.
250.
So 115 plus 62 plus 73 is 250.
Yes, sir.
Definitely. So 360 degrees
360 minus 250, 110.
gives us 110. Okay. So D is definitely going to be equal to 110 degrees. So, oh, we forgot to put the reason. The reason is the sum of the interior angles of a quadrilateral is what? 360 degrees.
Because of 360.
Okay, so write that down, take that down and send it to me, please. So D, we know that D is going to be 110. All right. And C is going to be equal to 118. Any questions on this and how we got it? Or are we good?
Good.
But
All right, good. So these would be familiar or unfamiliar?
familiar.
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 Familiar. Okay, good. All right, so I'm glad that
Oh,
y'all
don't move it.
don't move it. Okay. But I'm glad that y'all say this is familiar territory. Very happy for that.
We have any Pythagorean theories?
Pythagoras theorem
Yeah, we have any of those.
tonight. I'm not sure tonight. I'm not sure tonight. I'll teach through the questions. But more than likely when we get the paper two stuff, we can be doing Pythagoras theorem. Okay, let me know when I can move it, Ricardo.
We're moving out.
Okay, thank you. All right, so and when we say interior angles, what do we mean? Interior angles.
The angles inside?
Angles on the inside. Now C, is that an interior angle?
No, sir.
No. It's a exterior angle. It's on the outside. Okay, so the interior angles are gonna be these ones. And what we're saying is that for a four-sided figure, that's gonna be equal to 360 degrees. All right, so just bear that in mind.
What's with the
Go ahead.
how much angles the exterior? How?
How much angles? How much? You mean what is the rule for exterior angles? What are you trying to say?
Yeah, but how much angles does this exterior have in general?
I don't understand your question. Help me understand it.
Like usually I would have C, that's an angle, right?
Yeah.
So it only have one angle, an exterior.
Okay, this is one exterior angle. Okay. The way how this figure is drawn, it only has one exterior angle, but we could extend certain lines so that there'll be more exterior angles. So say here, right? Say so this angle would be an exterior angle. Say here, this angle would be one, and say here, sorry, this angle will be 1. Okay, so once they're not in the inside, they're exterior angles. Okay. Discard. Alright, so
Do they have any like this to just intersect the angle itself?
any what?
Do they have any ones that just intersect the angle?
I don't understand what you mean.
Like just a random line through the angle.
Through what? You mean through C?
Through the middle.
Through the middle of what? The quadrilateral?
Yeah, the quadrilateral.
So you mean just a line that separates it in half?
Yes.
That could happen. I mean, that could happen. It doesn't change anything. But that can happen. Okay, so we dealt with this.
But wouldn't that give you like extra angles interior?
Mm, oh, I see what you're saying. Yeah, certain angles would form. Angles would form at the intersection points because what will happen is that um, when you draw a line through it, a right angle would be here, and another right angle would be here, another right angle would be here, another right angle would be there. So, but I'm not sure if we add that inside. I'm not sure if we would add that into the thing. I guess it would. It would affect it because um, it still would be interior because it's inside. So I see your point. But in your case, they won't put no line running through it. It'll just be the straightforward, regular quadrilateral.
Boring.
Okay, so yesterday we did this question. I really wish that we did finish this question because to pick it up today again would mean that I'd have to go back over what happened yesterday. Okay, so all right, so let's go back to that. So yesterday we saw that point. Yesterday we saw how to calculate the radius of this cylinder, and we also saw how to calculate the surface area of the cylinder. Did we do the surface area of the cylinder? No, we didn't.
I looking and I don't see it.
We did the surface area of the cube.
I didn't see the one for the cylinder.
No, we didn't. Okay, that's good. Okay, so that means that we could pick up from here then. We did the radius, but we didn't do the surface area, and we
Yeah,
didn't.
we did the radius to the
Okay, all right. So
the
that's
one decimal place.
yeah. So we saw that the radius of this and the radius of this of the let me just go here. The radius of the cylinder is just equal to y. So y is the radius of the cylinder, and we saw precisely what is the value of y. All right, when we calculated, we got that y is equal to 10.8. All right, so that's the radius of the cylinder. Okay, 10.8 to 1 decimal place. So now they're asking us for something different. For this next question, we already know what the radius is. The radius is 10.8. But for this question, they're asking us to find the surface area of the cylinder. Okay, so let's consider that. We want the surface area. Now there's a formula for surface area of the cylinder that you need to know.
Oh boy.
What happened?
You coming again with these formulas?
Yeah. If you said yesterday, you'd have
Yeah, he would have leave
right.
class.
You'd leave class. Yeah. Well, we had those formulas yesterday.
So Mr. B, what's the point in maths then if everything got a formula?
No, see, the thing is, the reason why it appears as this formulas is because you're not at a stage yet in mathematics where you can construct your own or prove, right? So we just have to give it to you and say, okay, here, this works. But as you go, and if you go higher in math, then you will know how to prove a statement, how to prove a formula is true, and how even to derive your own formula. And so, but for now, we can't do that. We just give you the formula, tell you that, hey, this is what it is, use it. But what math is about is at least in part, it's about deriving formulas and deriving general equations, and so um, and proving that it works all the time. And once we get the results, then we can go to the engineers and we can go to the statisticians and say, okay, this is what works, and they just use it. They just apply what the pure mathematicians found. Okay. Um. Anyway, so we want the surface area. The formula for the surface area. By the way, the surface area just refers to um the area of the outside of the of the um of the shape or of the three-dimensional object. So in this case, we are referring to the cylinder, and so the surface area is going. Notice that the cylinder is made up of several parts, and so when we consider the surface area, we're going to be looking at all those parts. So surface area formula, and let me show you what I mean. So I want to break it down first um, before we actually use it. Okay. So okay. All right. So I think this does a good job at explaining um, what is the formula. So first, let's just state the formula. The surface area for us a the surface area for a cylinder is equal to 2 pi r squared plus 2 pi r h. Okay, so just remember that. That's the surface area of a cylinder. So let's write that down. So surface area of a cylinder so surface area of cylinder equals to 2 pi r squared so 2 pi r 2 pi r squared plus 2 pi r h. Where r is the radius and h is what is h?
Right?
The height. Yeah. Okay, so this is the formula for surface area of the cylinder. It's going to be 2 multiplied by pi multiplied by the radius squared plus 2 times pi times r multiplied by h. And so the way how we derive, or the way how we get this formula is that remember, what is the area of a circle? So the area of a circle in general, the area of a circle, sorry, what is the formula for area of a circle? Anyone know?
Pi r squared.
Pi r squared. So if we have a circle now, this circle, the area of this circle is going to be equal to pi r squared. That's the area of this circle. Now, in a cylinder, we have two circles. So we have one at the top and one at the bottom. So because we're trying to figure out the total surface area, we have to figure out the area of the top, this top circle. We have to figure out the area of the bottom circle. Okay? And so that means that it's going to be equal to, that means that we have to consider the area of the bottom circle and the top circle. The area of the bottom circle is pi r squared. The area of the top circle is pi r squared. And so that's why it is 2 pi r squared in the formula. So this 2 pi r squared in the formula takes into account the fact that we have two circles, one at the top and the other one at the bottom. Okay, so that's why we have in the formula 2 pi r squared. Okay, so that's the 2 pi r squared. What about this 2 pi r h? Why do we have that? Okay, so
The two sides,
now with the 2 pi r
Multiply
h,
it.
the height of the two sides.
The height?
no. Okay, so first of
Multiply
all,
by 2.
okay, so
The interior,
I mean
the
they got
interior and exterior.
no. Remember,
Square root.
no. Remember, if you look at the cylinder, not only do we have the two circles on top, okay, but we also have this thing around it, like it almost like it covers it, if you understand what I mean. It's but it's really a rectangle, to be honest, that covers it.
Oh.
So let me see if I can find probably a better straightforward image. Curved surface area, no. I guess this does it in some sense. Um, yeah, so this really break it down for you really to see it. So if we have a rectangle, okay, if we have a rectangle and if we have two circles, we are able to create a cylinder, isn't it? So that's why we have that's why that's why we describe the surface area like that. So the surface area is going to be the area of the surface. So each, and we basically script the image apart, right? And then calculate the area of each individual surface and then add them all up. So we first find the area of the top circle, which we know is pi r squared, the area of the bottom, which is pi r squared. That's why we have the 2 pi r squared. And then this yellow piece is basically a rectangle, really, okay? And so here we have the length of this, right? The length of this, and then we have the width of it, all right? Now, I'm trying to figure why you have 2 pi r times 2. And you have 2 pi r times 2 times 10. Oh, okay. That was 10 was the vertical height in this particular question that was given. That's why they have 10. Okay, times 10. Length times width. Okay. All right. Let's see again. Here. Good. 5 centimeters. Okay. So basically, only thing I want you to really understand from the formula is that R plus H, cross-sectional area. The only thing I really want you to understand is that when we talk about surface area is a combination of the areas of all the different parts of the shape. So the
Yeah,
curve,
but what I understand the top and the bottom, that's where you get two.
yeah,
But where you get the two from the rectangle? There's only one rectangle.
it is only one rectangle. So we have 2 pi r, h. I think it comes from the, okay, remember 2 pi r. 2 pi r
It's
is
coming back.
2 pi r is the circumference of a circle. And this rectangle, um, yeah, that makes sense. The rectangle is going to cover the distance of this circle, isn't it? Right? It's going to cover the distance of the circle. So that's basically the perimeter right there. So that's why we have 2 pi r, or the circumference of it. Then we multiply it by the height. Okay? So that's why we have the 2 pi r there. Okay.
So it's a circumference times the height.
Yeah, the circumference times the height. Because think about it, this rectangle, right? The length of this rectangle is going to be the circumference of the circle. Really think about it. Okay? So that's why the length is 2 pi r and the height is actually the width, which is h. Okay? I don't know if you follow. Like this length right here is actually going to be equal to 2 pi r. It's going to be equal to the circumference of this circle, such that once we close it together, the top part is going to um, fit properly with this closed.
That's a bit.
Yeah.
I still don't understand why it have 2 pi or 8. Like,
You know what? You don't have to worry about it. Just know the formula. It ain't really that important. Okay, the only thing that's important is that you know the formula and know how to use it. But at least you can appreciate the fact that what I read, the core ideas that I really want you to understand is that um, the surface area comes from adding up all the areas of the different objects once we split the cylinder apart. Okay, so we know that the surface area of the cylinder is 2 pi r squared plus 2 pi rh. That's the formula that we're using. And so let's put everything in. So we know that in this case, oh, I see why. We know that r was, from our discussion last class, we saw that r was equal to what? What's the radius?
Why?
The radius is going to be equal to y, which is equal to
1.8.
10.8, yeah. So the radius is still 10.8, what is the height in this case?
2i.
Height is going to equal to 2y, which is going to be equal to 2 times what? 10.8, which is going to be equal to what? What is 2 times 10.8?
What's the question?
What is 2 times 10.8? Hello?
21.6.
Good, 21.6. All right, good. So we have the radius, which is 10.8. We have the height, which is 21.6. Now, so that means we have everything that we need to calculate the surface area. So the surface area of this cylinder is going to be equal to, we keep the 2. What is pi? They told us that pi is what?
3.14.
3.14.
3.14. Yeah. On R is what?
10.8.
10.8.
R is 10.8. But remember here we're raising 10.8 to the power of 2. So it's going to be all right. Plus, I think someone is asking to join, you know. Okay. Let me take the register at this time, one time. Okay. So this is going to be equal to 2 times 3.14 times 10.8 squared plus, we keep the same 2, so it's going to be 2 times pi again, which is 3.14 times what? Times r, which is 10.8 times h, which is 21.6. Okay, so once we do all that, what does that equal to?
How do you even answer that?
So if I were you, I would the way I would do it is I would do the first part
The
first,
first one, I did the first part.
and then I'll do the second part last.
The first part equals to 732.4992.
Okay, let me check it. So if we were to go and use a calculator,
You do it the manual way?
the manual way, can't do it. Not that we can, it just take too long. 3.14 times 10.8 raised to the power of 2. That's equal to what? It's equal to, find what I got. That's what you got, Nancy?
Yes, sir.
Oh yeah, that's true. 732.992.
And the second part is 754.0992.
It's gonna be plus. Sorry, I'll have to move this up, okay? So let me move this up so we have more space. And let's make this bigger. So it's gonna be plus. So 2 times 3.14 times what? Times 10.8, so no squared, times what?
21.6.
21.6.
That's gonna be,
Isn't it plus 21.6?
not plus, not plus.
Or is it times?
All this is multiplication.
Okay.
Mhm. So we get 1,000 464.9984. So that's the one in green. And so we'll just add these two. Once we add them, what do we get? We get 2,197 point, sorry. Once we add them, we get 2,197.4976. And so this equals to that. And to be honest, it's supposed to be in, did they tell us the, yeah, it's supposed to be centimeter cube, centimeter squared. So centimeter squared, because area is always centimeter squared, or it's unit squared. So
Yeah, the odd bad, right?
yeah. Okay, so that would be the area of the surface area, rather, of the cylinder. How did we do that? All we did was we used the formula.
Mr. B,
Yes, sir.
when you're doing measurements, right? I thought you, never mind.
Okay. So the surface area of a cylinder is this formula, 2 pi r squared plus 2 pi rh, where the r represents the radius, and the radius is this length, and the height represents this vertical distance here. Now we saw last class that y equals 10.8, so the radius here is actually 10.8. That's what we saw last class. And so if y is 10.8, if you want to figure out what is 2y, that's going to be twice the length of y. So it's going to be 2 times 10.8, which is 21.6. And so all we need to do is plug in or replace everything in our formula. We know that the 2 remains. The pi is going to be equal to 3.14. The r is 10.8. We square it. The 2 remains. The pi is 3.14. The r is 10.8. And the h is 21.6. We multiply everything in here in the red, and we get 732.4992. Then we're going to add it to everything in the green. Again, we multiply to get everything in the green, and that gives us 1,464.9984. And then when we add these two together, we get 2,197.4976 centimeter squared. Okay. Any questions for me on that?
Yes, but never mind.
Okay. So, familiar or unfamiliar? How was that one?
I mean, it's an interesting play with the formulas we already know.
Okay.
It ain't really nothing new, but it's
Okay.
interesting how they interact with different things.
Exactly. That's true. The interaction of the formulas we already know is true. Okay, so let's come back to this question. So let's go back to the familiar territory. So hopefully this isn't as bad. Okay, so ratios. Who loves ratios? Anyone?
Okay.
You're so
Man,
quiet
is
today.
the ratio easy or not?
I like it.
You like it, Miss Cooper?
If they easy.
If they easy.
Yeah.
All right, so let's see. Let's consider this ratio. This should be pretty easy. These stuff are usually easy, yeah. Okay, so Miss Deems shared $20,000 between her two sons, Bob and Sam, in the ratio 2 to 3 respectively. Now, when they say respectively, what does that mean?
Equally?
No.
To each their own.
Yeah, something like that. So respectively means that when what the two symbolizes that Bob got the two equal parts, and the 3 symbolizes that Sam got the 3 equal parts. That's what we mean when we say respectively. Like the order matters. So Bob is 2 and Sam is 3. Okay? Someone's asking to join. So that's what we mean when we say respectively. Okay, so calculate the amount that Bob received. There's different ways to do this.
You receive 4,000.
You receive 4,000.
No, 8,000.
So we want to know what Bob received. We know Bob, he's gonna receive 2 equal parts. Okay. So the most common way that I've seen this done is that usually, in order to figure what Bob received, we would put the amount that Bob has, and we're gonna divide it by the sum of 2 plus 3, and we're gonna multiply that by the 20,000. So 20,000 over what? So it's gonna be, what is 2 plus 3?
5.
5. Very good. So 2 over 5 multiplied by
20,000.
all over 1. Now how much times 5 goes into itself?
1.
1.
Very good. How much times 5 goes into 20,000?
5,000 times?
Think about it. What times 5 gives you 20?
4.
Yeah, 4.
4.
So 4,000, right? Now we say, what is 2 times 4,000?
8,000.
8,000. So the amount that Bob received is going to be equal to $8,000.
I didn't do mine this way.
How did you do it?
First, I count the ratio 2 plus 5. 2 plus 3 and equal to 5, and I divide the 5 by 20,000 to get the rate of each individual
A 1.
ratio.
Mhm.
And each ratio is worth 4,000. So 4 times 2 is 8, and
Okay.
4 times 3 is 12. So
Okay. So you first figure out you first determine what is one equal part,
yes.
and then
That's how I learned to do it.
That's how I did it, like how we did it too.
yeah. So that's definitely a way. I don't know. In school they use, and at least when I was in school, they usually taught us like this.
I learned the way they talking about, but I just did it yo.
Okay. Um. But So first you have to determine what one equal part is. So the next option that was mentioned is You need to determine what one equal part is. One equal part. And one equal part, we basically take in 20,000 and we're dividing it into 5 equal parts. So it's going to be 20,000, okay, divided by 5. And that's going to give us what one equal part is. And so that's equal to 4,000. So now that we know what one equal part is, we know that we're trying to figure out what two equal parts is. So 2 equal parts is going to be equal to the amount that Bob received. So 2 equal parts is going to be equal to the amount that Bob received, which is going to be equal to 2 times 4,000, which is going to be equal to 8,000. So Bob would receive $8,000, and the other person would receive the rest.
12,000.
Okay, so
You received 12,000.
all right, can I move this? Let me know.
Yes, sir.
No, yes.
Yes, sir.
Yes, sir.
Okay, good. Okay, so next,
Okay, so next.
pardon?
I said the way I had to learn, I used to add the 3 and the 2, and then I divide because I get 5, and then I multiply 4,000 by 3 and 2.
Yeah, that's a good way. So either way works, both are fine. Okay. Okay, so the next thing is,
Mr. Petit,
yes, sir.
what if they try to expand that question and ask what's the percentage each person get out of the total?
Okay, that would be an interesting question. I'm sure you know how to do that.
Or just do it over 100 over 1?
So you would say 8,000 over 20,000 and multiply that by 100. You understand?
Yes, sir.
Okay. Okay, so now Bob did something with the amount of money that he got, which was what? Can't forget it, 8,000. So he invested his share for 2 years at 4% per annum, simple interest. Calculate the interest earned. Excuse me. So here they want us to do simple interest, and we know simple interest formula that's going to be equal to PRT over 100, where P is the principal, R is the rate, and T is the time in years. So we could say interest earned, which is simple interest, it's going to be equal to the principal, capital P, times the principal times the rate times the time. And that's another formula you just gotta know. All over 100. So here P is going to be your principal. That's the amount invested. So P is going to be equal to what? 8,000, right?
1,000.
R is going to be equal to the interest rate, which is 4%. And T is going to be equal to the time in years, which is 2 years. So altogether, we have, it's going to be equal to P, which is going to be equal to 8,000. R is going to be equal to 4. And T, which is going to be equal to time in years. And then we just multiply everything out. So how do we do this? There's several ways we could do this. Well, we could cancel out the zeros. So we know that this, we can cancel out the zeros. So we know that this zero could cancel out with this zero. Similarly, that zero with that zero. So we are left with 80 multiplied by 4. What is 4 times 8? What is 4 times 8? Hello?
32.
4 times 8. Sorry, 4 times 2, rather.
16.
4 times 2.
4 times 2?
4 times 2.
8.
8.
8. Wait, okay, 16.
4 times 2. All over 1. And then 80 times 8 is what?
80 times 8 is 640.
640. Y'all sure y'all ain't sleeping on me? I feel like y'all had it. I feel like y'all had all of it.
It's close on you.
Huh?
Well, was the stove still on?
Just toast. Oh boy. If they ain't cooking, they eating. If they ain't eating, they watching Netflix.
Mr. Petit, I never learned it that way, but I just do it like the common sense way.
Okay. All right. So the answer is going to be 640. All right.
Okay.
Yeah. So just use principal times rate times time all over 100.
But isn't that also just asking 8% of 2,000? 8,000? I mean, 8% of 8,000?
8% of 8,000. Yeah. 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 That's 8% of 8,000. Yes, that's 8% of 8,000. That's true.
I prefer to do it that way because this PRT is too
No,
much
it's
for me.
for you, for your exam. Sometimes they switch it up. So they may ask you for what's the rate, or they may ask you what is the time, or what is the principal instead of the interest. So it's important for you to know this formula because once they start switching the variables, you're gonna need to know how to. You need to know the formula to be able to change it to the subject, so that you can figure what the answer is. So that's why I go the formula way. Okay.
Oh, boy.
Yeah. So all right. So Okay, so the interest earned was $640. So calculate the amount of money he had at the end of 2 years. Okay, so how much did he had at the end of 2 years? Whole 2 years pass. How much does he have? Okay, so let's see. So the amount of money he had at the end of 2 years is going to be equal to it's going to be equal to the amount that he invests, right? Did he invest that? What did they say? Yeah, the amount invested plus the interest earned. So what is the amount invested? Wasn't it 8,000?
8,000.
And the interest earned was what?
640.
640. So it's going to be 8,000 plus 640. It's going to be 8,000.
8,640.
Okay, so let me see that exercise. Excuse me, send it to me via WhatsApp.
He invested in 2 years, and that's all he makes.
That's all he made. That's
You might as
it.
well just, you might as well buy a hot dog stand, man.
Yeah,
Or soda machine.
it's deplorable. Um, okay, so 8,640. Send in the notes for me, please. I want to see the notes of the exercise. The one on the simple interest. So send that in for me, please. So familiar, unfamiliar, or how was that one?
Familiar.
Very familiar. Yeah, definitely. Okay, so that's good. So these questions should be familiar, the interest questions. All right, so let's move on. Okay, so that's that. Pretty straightforward. So let's go back to our surface area question. So they said that we know that the surface area, we said that the surface area of this thing is going to be equal to 2,000 and some centimeters squared. Now they're saying that they want us to calculate the amount of packaging saved by using the cylindrical form. So calculate the amount of packaging saved by using the cylindrical form. So there was two forms that was suggested. The first form was the cubic form, and we found the surface area of the cube and everything. And then the this time we found the surface area of the cylinder. So they're saying that there's an amount saved from using there's amount saved if we use the cylindrical form rather than the cubic form. And so in order to answer that question, we have to take the surface area of the cube and subtract that with the surface area of the cylinder to figure out how much was the amount saved by using the cylindrical form. So let's do that. So calculate the amount saved by using the cylindrical form. So amount saved is going to be equal to surface area of cube minus surface area of cylinder. Okay, so the amount saved is going to be equal to what is the surface area of the cylinder? Sorry, of the cube that we saw yesterday. That was, anyone remember? Surface area of the cube. We got, that was 2,400 centimeters. That was 2,400 centimeters. Did they tell us anything with that? Okay, okay. And then the surface area of the cylinder we saw was 2,197. So we're going to subtract the two. So the amount saved is going to be equal to, what is the difference between them? Anyone?
You mean without the decimal place?
You include the decimal. What y'all got? Hello, anyone home?
I don't know.
202.5024.
Yes, very good. So 202.5024 centimeters squared.
Mr. Badid,
Yes,
but I
sir.
wanted to ask earlier, and I say never mind was about this,
Mm-hmm.
How can this be more accurate than the value of pi used?
How can what?
How can this amount be more accurate than the amount of pi the decimal? We only use two decimal places, so how you could use four here.
Doesn't matter. Um, there's no, it doesn't make it
So
wrong.
so they ain't really accurate then.
What? What you mean? You mean this question?
Yeah, the answer to it. Because we only use two decimal places of pi to
Oh,
find the answer. So then the answer came out as four. So
the answer came out as 4? What you mean?
four decimal places.
Okay,
But you only use two decimal places of pi.
all right. So I see what you're saying. It is okay. So sometimes, all right. Sometimes we could get away with. I use this loosely. Sometimes we could get away with murder. What I mean is, sometimes we only want our answer accurate to a certain amount. So, and so therefore, using two decimal places for pi is accurate enough for what we want to do. Now, sometimes when accuracy really matters, then we'd use more decimal places. But sometimes sometimes the accuracy of the surface area or the volume is something that we just need a rough estimation of. We don't need it to be infinitesimally accurate, if you understand what I mean. So in those cases, we just shorten it. Okay, it's still
All
accurate.
right.
It's still accurate. It's just accurate to a certain amount of decimal places. That's the thing. Um, so it doesn't make it wrong. All right. Okay. So that was just basically subtracting it. Thank you, Julia Raming. Thank you, Miss Moss. Thank you, Ricardo, Alicia, and Lakeisha Stubbs. The rest of you, please send in the notes. Don't be delinquent students. All right, so let's move on to another one. Oh, no, we definitely can't do this tonight. But what we could do, we can't do this tonight because it's gonna take too long. But, or maybe we should. We have 30 minutes left. I think we could put this off, but this will be have to be our last question. Okay, so this is a good question. The reason why I say this is a good question is because this question shows us, no, 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 no.
We doing it or no?
I thought this was a linear equation. It's not. Um, Let me see what comes out. Better we do the probability. Let's see what comes after that. Okay, these simple ones. Yeah, better we just do the algebra instead because we could easily finish that. Okay, so let's do the algebra ones, and then when we come back, we'll do the probability and the graphing because those.
Excuse me, Mr. Petit. Can you go to the last question so I can take a picture, please?
What's next thing? I haven't heard from you all night. You all right?
Yes, sir. I thought I was on the laptop, not realizing my microphone malfunctioned.
Oh, okay, okay.
So that's why I had to sign on to my phone.
Okay, go ahead. What you asked me to do?
If you can go to the last question that you just answered, I want to
Yes.
take a screenshot.
Oh, okay. Thank you, Abigail. Thank you, Sean Collins.
You can move it. Thanks.
Yeah, so let's consider these algebra. We won't do the graphing tonight. It'll take us too much time, and the probability is involved, so we can leave that. Um, what is this one? Calculate given here. This one, yeah, I don't want to touch this either. Let's just do the algebra, the nice and easy, quick, so that we can be able to finish in time. So here we have, notice what this is, right? This is you're subtracting two fractions, right? But not just two fractions, not like two fractions, two regular fractions. These are algebraic fractions in the sense that they have a variable in it. Okay. Now, the same principle applies when it comes to subtracting algebraic fractions in comparison to regular fractions. We know that when we want to subtract regular fractions, what must we first do always?
Try to get the same denominators.
Try to get the same denominators, right? Try to get the same denominator. So in the similar manner, we are going to do the same thing, try to get the same denominators. If we don't have the same denominators, we cannot subtract these two things. Okay, so just bear that in mind. All right, so this is what we have. So we have to try to make the denominators the same. Okay, so here the denominator has x minus 1. Here the denominator has 3 minus x. And so we need to make sure the denominators are the same. Okay, so a straightforward way, this is not the only way to do it, but for me, this is the most natural for me. This is the one that I remember easiest. What I'll do is, first let's just write the question. So we have x minus 1. X minus 1 divided by 3 minus x. So remember, we want to make the denominator the same. Denominator is the same. And what I will do is, I know that if I have this, so if I have, say, if I put, let's say I put 3 minus xl, let's say I put that down, right? What must I put here to make these two the same?
X minus 1.
X minus 1.
Minus 1.
Good. So I need to put x minus 1. So x minus 1. Now, so now currently they are the same. But the thing about math is that you can't just be putting stuff wherever you feel like. You have to make sure that at the end of the day, it makes sense. So what I mean is that, yeah, we did make sure that the denominators are the same. So this is 3x minus, this is 3 minus x times x minus 1, and this is 3 minus x times x minus 1. But the problem is, whatever we do to the bottom, we must do to the what?
To the
Top.
top as well.
Top. Good. So here we inserted x minus 1. So at the top, we got to insert x minus 1. Okay, so whatever we do to the bottom, we must do to the top. And of course, this is multiplied by each other. Similarly, we have a 3 on top here, and we put 3 minus x, so we got to do that to the top. 3 minus x. Okay?
So, Mr. Petit, question. So, you have to put at the top, like, oh, under the 3, you only put the 3 minus x on the left
Yeah.
side.
Yeah.
So that must be to the top on the left. And
Yeah.
then the x minus 1 on the right must be to the numerator on the right.
Yeah, because this is the only new thing that we put. We put this here. You see what I'm saying? So
Okay.
since we put it, we have to kind of balance it out. So if we put it at the bottom, we have to put this at the top. But here, the x minus 1 was already here, so we don't need to worry about that.
Okay.
The same thing for the 3 minus x. It was already here. So the only thing that we put the x minus 1. So since we put the x minus 1, we have to balance it off. We have to make sure that, you know, it's mathematically correct. So whatever we do to the bottom, we must do to the top. So that's why we only do the x minus 1. Okay, so let's rewrite this. So this is going to be equal to, notice that I'm going to switch the way I write this. Or, you know, better yet, let me just leave it because I don't want to have to write so much things. We can say 3 times 3, which is what?
9.
9.
9.
And then 3 times negative x, which is going to be what?
Negative 3x.
Negative 3x.
Negative 3.
Good. All divided by the same thing, open bracket,
The same thing.
3 minus x, close bracket,
So let's say
minus 1. Yes, ma'am?
we ain't changing that, right?
No, we ain't changing that. That's the denominator right there. We ain't changing that. Minus 2 times x is
2x.
2x, very good. And 2 times negative 1 is
Negative 2.
negative 2. That's going to be equal to 3 minus x, close bracket, x minus 1, close bracket. Now the denominators are the same, so that means that we could put one fraction bar, right? Because this denominator is the same thing as this denominator. So we only need one fraction bar, one big old fraction bar. So because the denominators are exactly the same thing. So it's 3 minus x, open bracket, close bracket. Let me put them close because we have to put them close to symbolize that we are multiplying them. So it's going to be open bracket, x minus 1, close bracket. Now what we have on top, we have 9, negative 3x, and negative, oh, we have to be careful. We have to be careful. We have to be careful. We have to be careful there. Because this is negative, right? So what this really means is it's actually negative, open bracket, 2x minus 2. The whole thing is negative, okay? And it's going to be 9 minus 3x. And so we ask ourselves, what is 9 times? Sorry, what is negative 1 times 2x? That's going to be equal to what?
Negative 2x.
Negative 2x, yes. So the like terms would be negative 3x and negative 2x, right?
Yes, sir.
And then we have the positive 9.
And a negative 2.
Gotta be careful.
Positive
Negative
2.
and a negative.
Plus.
Positive 2.
Yeah, positive 2. All over 3 minus x.
And x minus 1.
And my x minus 1. Okay, so now we can simplify. Negative 3x minus 2x is going to be what?
Negative 1.
Negative 5x. Because it's negative 3x minus 2x. Okay, so negative 3x minus 2x, so negative 5x. Because you owe someone $3 and you owe an X person $2. So in general, you owe $5. It's going to be negative 5x plus 11 all over 3 minus x close bracket x minus 1. All right, and so that's our answer. We can simplify it further. So familiar, unfamiliar, good, decent, bad.
Unfamiliar. It was easy.
All right.
I just
Can you go back on the place?
Definitely. So the first
I
step,
have it.
okay, good. So the first step is trying to make sure that we get the same denominator on both sides. That's the first step. Once we get the same denominator, you're basically good to go. Okay.
Mr. Petit,
Yes, ma'am.
it wouldn't make a difference if on one side, like if you have 9 minus 3x, and then you have that over 3 minus x and x over 1, and for the other side, you have the x minus 1 and x. Would it be the same thing?
Say it again.
Like if you have the 3 minus x and then x minus 1, and you switch it and put the x minus 1 on the side before the 3x, would it be the same thing?
It wouldn't make a difference. Because it wouldn't make a difference if they are switched because 2 times 3 is 6 and 3 times someone mic is on. It's on. If you're not, who's that? Yeah, it wouldn't make a difference. So she's asking, if this was if like we have 3 minus x and we have x minus 1, and here we kept it as 3 minus x and x minus 1. She's asking, but what if you switch them, right? And the idea and the answer is that it doesn't change it because multiplication is commutative. So that is to say, the way how you multiply numbers doesn't matter. So 2 times 3 is the same thing as 3 times 2. So that means that 3 minus x times x minus 1 is the same thing as x minus 1 times 3 minus x. So it doesn't change that. Okay?
Yes, I just want to know.
Good night. Sorry I'm late.
Good night, Destiny. All right, so let's go back to our familiar questions. Just add to insert a sort of an unfamiliar one. Okay, so let's go back here. Okay, so this one is familiar, right? Right?
Yeah,
Yes? Well, you sure?
yes, sir.
Okay. Yeah, these should be very familiar. They like to bring these type where you have two objects, one inside the other. Find the area of the outer part, then find the area of the inner part.
We can use the Pythagorean theorem on this too, right?
You could, but
I remember doing this
you don't need
with
to.
you.
Because they're not asking us for the missing side. So you don't need Pythagoras theorem. And they're asking us for area. So Pythagoras theorem deals with length of sides, not area. Okay, so the diagram below shows the dimension of a triangle piece of property, a triangular piece of property. That would be nice. The property that's triangular in shape. And a rectangular shed. So here we have a piece of property that is triangular in shape. Okay, and it has a shed in the middle. And so the first question is calculate the area of the property. And so that's the area of this entire triangle. Okay, so that's the first question. So calculate the area of the entire property. So how would we figure out the area of the entire property? What would that be?
You use a formula.
Well, that's true. And what is the formula for area of a triangle? Anyone remember?
It's base times height.
Close.
Length times width.
No, definitely not. Um,
I forgot.
I'm just multiplying the side by the bottom.
and then you do what after that? So area of property is going to be equal to base times height over 2. So that's the area of a triangle. The area of a triangle is base times height over 2. Or we'd say half base times height.
Why the half?
That's the formula. Okay.
What's the science behind the formula?
I don't know why they have the half. Um, um, but I'm sure there's a sensible reason why.
Because it's half a like a whole. Since it's a triangle.
I don't know. I don't know. Maybe I don't know. I can't tell you. Maybe because it's two of it makes a quadrilateral. I don't know. That's if I want to find, you can look in any geometry textbook for the rationale behind the formulas. They do a pretty good job when they explain it too. So, but here we just need to know the formula and know how to apply it. So we still keep the 2. The base, we have 13 meters. So the base is going to be what? 26 meters. That's the base, 26 meters. And the height is going to be this vertical distance here,
13.
13 meters, okay? So 26 meters times 13 meters. It's going to be equal to 26 times 13.
338.
Pardon?
You said 26 times 13?
Yes.
338.
Yeah, that's correct. So 338 divided by 2. And we cannot forget our meters squared. Now we divide this quantity by 2 to leave us with what?
One 169.
69.
So what is it?
169 meters squared.
Yeah, 169 meters squared. That's 169 meters squared. So
You
that's
divide it, so even though you divide it, you still got to put it to the meters square.
yeah, the meter squared doesn't change.
All right.
So 169
Is
meters.
that because they're inverse operations?
No, because you're just considering the whole numbers. I mean,
Okay. So you're not in the cross out the meter squared then.
yeah, not in the crossover. Okay, so
Also, why they put base? Why they have them different? Like why they have base times height and length times width? If they fundamentally the same.
that's height and base times. I mean, it depends on the shape, right? So, um, but shape with the shape, we usually consider we don't usually consider a base for the a rectangle. We just usually call it length times width. It just depends on the shape, right? So for a triangle, we use the words base and height, but for the rectangle, we use the word length and width. That's just convention.
Yeah, that's what I'm saying. But it would have been more easy to recognize how to use this triangle if it was the same word. Because if you know half the length times width would be triangle because half of the quadrilateral. You know.
I see you coming from. I guess the idea too is that um height also has a part to play too with the word because because you're not just considering any um any any length on the triangle. You're considering specifically the um the height. What I mean is that
Okay, I see.
yeah, okay, so all right, so 169. Now we have so let's consider, okay, we have time. So the property, so now we want the area of the shed. Okay, so the area of the shed. The area of the shed. So graphically for me, I come and write back the area of the shed. Remember what shape is it? It's not a triangle. Okay, so what is the area of the shed? We're done, right? Hello? Hello?
No, sir. Nothing.
No? Okay, but at least what is the shape?
Would it be aren't you multiplying 9 by 15?
Gonna be a rectangle.
Yeah, it's a rectangle. So it's gonna be length times width, right?
Yeah.
Yeah. So area of the shed, it's a rectangular shed. So we know we're dealing with length times width. Excuse me, sorry, which is 15 meters times
9.
meters. It's gonna be equal to what is 15 times?
5.
Say it again.
20. Oh, times.
Yeah, 15 times
135
Yes. Yes.
135 what?
m squared.
M squared or meters squared. Remember, area is always units squared. So if you was dealing with centimeters, it was going to be centimeters squared. Here we're dealing with meters, so it's meters squared. That's the area of the shed. And as expected, the area of the rectangle, the area of the triangle is bigger than the area of the shed because the area of the triangle was 169 and the area of the shed is 135.
135.
See? So let's kind of shade it in just so you could get a perspective. When we say the area of the triangle, we're referring to all of this area. So all of this, including the shed, everything. That's the area of the triangle. Now the area of the shed is going to be this purple piece, only that small portion. All right,
Okay.
that's the area of the shed. Now we still have some area left out. So the area that is inside the property, but not inside the shed. So I'm gonna do it in green. So this one right there, all right? This in green is the area inside the property but outside of the shed. You see? And so the question is, how are we gonna figure what that is? Subtract, okay? Subtract the area, the big area, the area of the triangle, and
Here's the
with
property.
the area of the shed.
Yeah.
In fact, that's the very next question.
Mr. Petit,
Yes, ma'am.
I just a quick question. Is it okay, why are okay, I told them asking for the area of the properties, right?
Mhm.
But why is the formula different for like between the shed and the property? Why is it different?
Because the shed is a rectangle.
Oh, so okay, so length and width applies to rectangulars,
Yeah.
and base time height will apply to like triangular things, basically.
Because that's the area of a triangle. The area of a triangle is base times height over 2. Right.
Oh, okay, I see. I see now. Thank you.
Yeah. Good question. So we want the property around the shed. So the area
34 centimeters square.
of the property, pardon?
34 centimeters square.
Okay. around the shed is going to be equal to area of triangular property minus area of the rectangular shed. It's going to be equal to, we saw it before, 169 centimeters, meters squared minus, right, minus 135 meters squared. And when we subtract them, we get
The 34
minus
meters square.
135, 34, right?
Yes.
34
Meters square.
squared, yeah. Okay. Any questions for me on that?
Yes, sir. You want a picture though?
Not yet, we're not done. We have one more part to it.
Just supposed to see what we doing.
Okay, we're trying to find the area of the green part. Okay, so we're trying to find the area of this part in here. Not the area of the purple, but the area of the ones in green. Right?
Okay.
Yeah. So that's what we're trying to figure out. Listen, sorry. Now here they said that grass is sold for $2.25 per square meter. Calculate the cost to cover the property around the shed with grass. So grass is sold for $2.25 per square meter. So for 1 square meter is $2.25. For the next square meter is $2.25. Now, how much square meters is the entire property? No, they say to cover the property around the shed. So how much is the area of the property around the shed?
One.
169.
34. Around the shed, the area of the property around the shed.
Oh, sorry.
I thought it was 169, but okay.
9 meters, no.
No, 34 because that's the area around the shed, not the area of the triangle or the area of the shed. The area around the shed. We want to cover that with grass.
That be
Oh, I had
7.5
16.
meters.
So it's gonna be. So how are we gonna figure that out? You're saying
Times it.
times it. Times what with what?
Times
I get the question, please.
$2.25 by 34.
Yes.
You do 76.5.
76.5.
Yes, sir.
Wow, you get that fast, miss.
I get the question.
I ain't even blinking. You already saying the answer. So cost.
I ain't even read it yet.
I know. I still think you can try to answer the question. Alright, cost. To cover the property around the shed is going to be equal to $2.25. And that's going to be the area of, that's going to be how much the grass is sold for, $2.25. 25 cents per square meter. I'm gonna multiply that by how much square meters we have, which is going to be which is
34.
34.
34.
So 34 times 2.25 is 76.5.
76.5, yes, sir.
So you gotta pay $76.50 to cover the whole property, which is not bad, in my opinion.
So, Mr. Petit,
Yeah, go ahead.
I got that.
what's the volume of this triangular prism?
You know the triangular prism.
Or what's the volume of this plot?
The volume of plot of land. No, it's just a surface. So you only talk about volume when you're dealing with a three-dimensional shape, like something like a container, or like something that holds water, or something that holds some sort of liquid or something like that. But the grass is an open space, so and sorry, the field is an open space, so it's really hard to really talk about its volume. Unless it was like contained, then we could talk about the volume. We could talk about its area though. And
All right, that makes sense.
yeah, no man, it can't be 7. It can't be 8 o'clock. How?
It's 8 o'clock.
No man, it just was 7:46.
Like a few
Okay.
minutes ago.
But you understand time is go fast.
No, the thing is, I keep on telling y'all that my laptop, it has a problem, so it is skip numbers, so it's really supposed to be like 6 o'clock. This really means 6 o'clock.
We got the same time, so I don't remember my laptop
Yours are
being.
not working as well, so you need to get that fixed.
My phone got 8 o'clock too, so that
I could show you all proof. Let me show you all the real time. Okay. Anyway, so
At the same time too, so
if you are not doing social studies and religious, you are free to leave. Yeah, so tonight is the last class for the week, and so I'll see you God's Spare Life on Monday for those who have the leave, which is week 6. Could you believe it? And so
Yeah.
take care and have a wonderful night. Make sure to send in the maths notes.
Okay, good night.
Good night. Have a wonderful one.
Mr. Petit, when
Yes.
you bring up time, right?
Yeah.
That remind me of something that, and because the satellite traveling so fast in space,
Yeah.
the time it have different on Earth, so they have to convert it to our time.
Okay.
It ain't a 1-to-1 ratio.
Okay.
Mr. Badi,
Yes, sir.
can you send me the recording from last night in the night, please?
Actually, that recording, it didn't save, and the reason why it didn't save because I was using something different, and when I tried to save it, it says it's not responding or whatever. So, that is unavailable. But tonight one is gonna be available because I changed the software. So very sorry about that.
Okay.
Are
then.
you able to even
You
just
want
send
the pictures?
yeah, I just meant to ask that.
The what?
The pictures on the PowerPoint you did it last night.
Okay, I could send the PowerPoint to you.
Please, I would really appreciate
Please
that.
Okay.
send that to me too, please.
Yeah, can you? I wanna, or even if you just send the passage you got, like just for review sake.
Oh, the passage is there too.
Yeah, because like it's very different. It's something I need to work on. So if you could
Oh,
just send that.
yeah. I'm so sorry that that thing didn't save.
Good night, Mr. Badi.
Yeah, have a wonderful night. Mm-mm. Okay, so let's continue. Okay, so we're gonna begin with social studies, and then we're gonna dive into um RK. I can't wait till RK. RK is usually a good ending. All right, so but first let's begin with our review questions. I wanna put a surprise quiz on you all. So
I ready.
Same.
yeah. This is a surprise one. This is stuff we learned from. We learned this from way back when,
Oh, you went too far.
Oh
and let me see
goodness.
if you all remember.
Okay. Why you going so far though?
I gone so far. I gotta make sure y'all up to date.
Gotta prepare yourself for them 50 you're gonna be seeing.
Yes. Okay. Okay, so this should be. Y'all can see my screen or it's not sharing.
It's not sharing.
Yeah, see it. You stop there.
Okay, so uh, I gotta go deep for these files.
So how come we never do none on religion?
Um, are you gonna be the one to make the quiz?
I mean, no.
The quiz take time to make, you know. They don't just pop out of the sky.
I thought you finding them.
No, I make them. I can just find them.
Yeah. Oh.
Yeah, I write the quiz. Not
Actually,
time.
that on Saturday you could sit down and do it.
Yeah, because Mr. Petit doesn't have a life. He doesn't have no life. So that's
Come on,
Saturday,
Mr.
when
Petit.
before you go to bed, you could do that.
wow. After 3 hours of teaching, just make. I don't understand. Y'all funny, man. All right. Okay, so let's see. We need a hard one, man. Something hard.
Oh Lord. I mean, it's good, but like, nah.
I mean, yeah, but like, no. Like,
No. Okay,
it
tell me.
could be
Come on.
hard with people. Just don't go overboard.
Don't go overboard. Okay. All right. I can try not to go.
Oh no.
Or you can maybe do that more.
I can try not to go overboard. Okay, so let's go. Excuse me. Sorry. All right. So this one has, I think, 16 questions.
That's it?
So.
Don't miss and click now.
This is hard. Okay. Remember this from way back when. When we was talking about history and what is history and all those different things. All right. So the question is, our dating system is based on the blank, and therefore applies to the Christian world.
BC.
B.
B. The marriage of Zeus.
B.
No, BC, like
B.
before Christ, and
So
AC
which
after
answer?
Christ.
Is it
So it's
the
based
death,
off the birth of Christ.
the birth of Christ?
D.
D. All right.
All right.
True or false? People from other cultures and religions date their calendars on different events that are important to them.
True.
True.
That's true.
True.
True. All right. They use the letters BC for events that happen after the birth of Christ,
Before
before the
Christ.
crucifixion of Christ,
D.
after the
Before the birth of Christ.
B.
D.
D.
It's D.
D or
D, sorry.
D.
Setting us up. D.
D as in dog or B as in boy?
D as in dog. Yeah.
He hasn't.
What? Oh my god.
All right.
Come on.
Okay. The letters
Y'all trying to make
AD.
the same mistake, Mr. T?
C.
The letters AD
C.
is short for the Latin
Anno Dom.
Domini.
Yeah, C.
C?
Yes, sir.
All right, y'all pretty good.
Yeah, you don't get us on this one.
What does Anno
Oh, God, I got
Domini
it.
means?
Oh Lord.
In the year of
A.
our, in the year of our Lord, in the
A.
year of our
A.
Captain, in the year of our Prince, or in the year of our King?
A.
A? You sure you want to
Yeah,
put
I
an
think
A?
it's A.
Yes.
Sure, 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 sure.
Too
Actually,
easy.
sure.
Too easy.
Sure,
I
sure,
ain't too
sure.
sure
A.
about A.
Yes, we sure. I sure.
Yes, in the year of our Lord.
Never mind.
Okay, the letters AD are used for the events that happen after the adoption of Jesus, after the ascension of Jesus, after the atonement of Jesus, or after the birth of Jesus.
B.
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 B?
B.
Yeah.
Yes, sir.
I was so sure about that.
No.
How?
Yes.
What it is?
Oh yeah, because I
After the
think
birth?
birth of
BC
before
means
birth of Christ.
BC
Well, that
means
makes sense.
BC means
Makes sense.
before. AD is used for events after Jesus' birth.
Yeah, I was just thinking that.
What does the
uh,
convention BP
Come
mean?
on, man. Come on.
Y'all
I
get
know
slaughtered.
just why I stuck.
Slaughtered tonight.
A.
A?
Yes, I.
What?
A? Someone said A. I heard someone say A in the background. But think about it. B and P. B and P. What do you have B and P in it? Just think.
B.
B. Before.
He might be trying to swing us
So, what the correct answer should be?
before the present.
You sure?
I think it's
Why
B.
you second
My
guess?
hand is dirty.
What is it? What is it?
B.
Oh boy.
I hear someone in the background
B.
saying B, so let me go with B. Yes, before the present.
Oh, I almost had a heart attack.
What does the convention CE mean?
Common error.
Common era. Very good.
Common error.
What's that?
What does the convention BCE mean?
Before common
D.
error?
Before common error.
Before common error. Too easy.
Good. In what
Easy.
era do we live in?
21st century AD.
Okay.
A.
Is it C?
It's A.
C? I
Wait,
heard
no,
someone
I
say
lied.
C. I heard someone say
It's
C.
A. It's A.
No.
A.
What you doing? What you doing?
What is
A.
it?
I think it's C. To me, at least.
A.
A? A or C?
A.
Nobody never say C?
Alright. A. Alright, we live in 21st
Oh,
century.
hell no, for C.
Live in the 21st century, okay? Alright. The 21st century includes which years? Is it 2000 to 2000 to is it from 2002 to 2100? Is it from 2003 to 2103? Is it from 2001 to 2100, or is it from 2000 to
It's
2000?
D, right? D or C? D.
Which we going with, C or D?
D. Man, hold on that.
C.
Nah, I ain't too sure about this
I
question.
think it's
Alright, let's ready. We're ready out. Let's think.
Ding, 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 ding.
I remember this question exactly, and we did the same thing, and we get some wrong. I forget which one it
Man, we
is.
just doing so good, man. Not
I got
this.
it. C. I
C
believe
now.
in C.
Yeah, lock and C.
Yes, I lock it
Yeah.
down. Yes, let's go.
Oh, finally.
Alright, good. So the
I don't
idea is
even
that,
had that wrong.
That was powerful just now.
okay, so, alright. The first century AD was from what?
D.
D?
No.
Yeah, 1,000.
Wait, I know.
Wait,
Yeah,
wait, wait,
because
wait.
the century thing is go from
Oh yeah,
one.
yeah.
A
D.
century is a
Oh yeah, D,
Yeah,
D.
I
century
think
is
it's D.
Yeah, that makes sense.
okay.
All right then.
The 10th century was from
Oh Lord. I gotta think on this one.
I remember this question too.
mhm.
Alright.
I think.
A?
I can't think. Hold on.
A.
Yeah.
Yeah, I think it's A.
Hola. Oh, yeah.
Oh
Yeah, because you always, if it's a 10th century, right? What you do, you keep the century that you're on, and then you always go 0, 1. Okay, so inside there. All
Okay.
right. Each century contains 100
Oh,
years,
B.
5,000 years.
yeah.
B.
It's B.
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 Yes. So
B as in dog.
What?
I wanna
Oh,
believe.
He
he
just
must
was
not
getting
listen to
mixed
what
up
he
today.
listen, but he say B as a dog.
Here we go again.
each millennium has what?
Oh goodness.
A.
A.
Wait.
Wait. Is A. Oh, it's right.
And
What it was?
the 4th century BC was from.
What thing?
Now you gotta be careful
D.
because
A.
BC, BC, not AD now.
A.
D. I heard
A.
someone say. We going with A or D?
A.
A.
No, I lie. I know it was C. I just knew it. Time to say it.
C, because we switch it. Okay, because since it's BC, we switch it around. So it's gonna be the O1 is gonna be on the BC. It's gonna be on the previous one, and the 00 is gonna be on the first part. So be careful with that. 88.
A minus. We can take that.
All right, nothing wrong with that. Okay, so let's okay. Let's see what the course that we have for today. So actually,
Only take up 15 minutes? Oh.
you wanted it to take up all the time, Miss Cooper.
I'm not saying that.
Is that what you're implying?
No,
Is
it
that what you're?
didn't. That didn't go to my mouth. I only said it only take up 15 minutes.
All right.
Now, if that's what you get from that sentence I just said, that's on you.
Okay. All right. So we are supposed to talk about the Cacique, youth leadership, and all those good stuff. The perks that he had and stuff like that. So today is Monday, Tuesday, Thursday. I can't believe it is Thursday already. The 10th of February. The beautiful month of February. Subject is it's on Lucayans, but I mean sorry, subject is social studies.
Oh, sure.
Yeah. And then the topic is the cacique. Okay, so we're gonna be talking about the cacique and his privileges and who would um who would who would be a cacique and all those different stuff. So let's begin. So the Lucayan ruler was called the cacique. Now the cacique ruled over a village or what? Or several villages. Now what is the name that we give to several villages? That's a province. Now this position that he had was hereditary. So he didn't have to fight for it. He didn't have to, go and battle for it. It was hereditary and was passed on from mother to father, or how was it?
Father to son, right?
Yeah, passed on from father to son.
Basically, and it was if he didn't have any more sons, it would go to his sisters, something.
Yes. So, or, right, like we say, or in the absence. So, in the case where we didn't have a, in case where he didn't have a son or the son died or whatever, in the absence of a direct heir, it would go to the eldest son of the cacique's eldest sister. So it go to the eldest son of the cacique's eldest sister. Now, could a female become a cacique?
No,
Yes, they could. A female could also become a cacique, but it was rare though.
I never really hear about it. So
As in the case of a Nakona, who ruled
So, Miss Subati, I have a question.
Yes, ma'am.
So, what if they have like no children and there's an only child? What would happen?
That's a good question. No children. I mean, they would have find some way.
Don't go
There's always some family.
They would always have children. They use their cousin.
They cousin, something. The oldest cousin.
There's always there's always someone. There's always someone. Trust me, there's always someone. But thanks for the question. That was a good consideration. So, like for example, this lady, she ruled after the death of her brother. Okay, so they'll know what to do. The family of the cacique people, they'll determine something. They'll figure out something. They'll figure out a way to get it done. So Lucayan society was, we saw this last week, hierarchical. What does that mean? Can you remember?
What's the question?
What does it mean for it says the Lucayan society was hierarchical. What does that mean?
It goes by generation to generation.
No, it means like there's levels, right? So this means that power, privilege, and responsibilities. Power, privilege, and responsibility were different. Depending on your position in society. Under the cacique were the nobles. So right under the cacique was the nobles. The word that they use for them is the Nitanos. And after that, we have the priests. And below them were, of course, the ordinary people.
So basically, they used to assist the nobles used to assist the Kazika or something. Eh?
Yes, definitely. The cacique was also the chief priest. Okay, that's also important. Why ever twice? Now, the other Lucayans had to obey the cacique without question. So he run things, he controlled, he's the, something similar to a king. He or she, so the jobs of the cacique would be to share out the land. So they would share out the land. What else would do? The cacique, besides sharing the land. It also be a part of their responsibility. They would share the land. What else?
I honestly don't know.
They would share the land. They would, besides sharing the land, what else do you think needs sharing? Sharing.
This things they had.
Sharing the food. And jobs.
He construct like the sacrifices.
Say it again. Yes, you're right. So he or she decided on. They decided on the they decided on when they go into war and who they gonna fight, and they also decided on, hey, listen, we just might just take it easy and just be peaceful. They decided on fixed days of worship, and they led their ceremonies. Now, in return, so for carrying out these duties, they didn't just do it for free. So they had a reward. They had rewards, many rewards for doing this. So in return for these responsibilities, so in return for these responsibilities, caciques had many privileges. So for example, they were given food. They had a large house built for them. They had special clothes. They had more ornaments. When we say ornaments, what do we mean?
jewelry and stuff or
Yeah.
decorations.
Yeah, they had more ornaments than others. They had a larger canoe.
That's the first time I had a one.
Which one? Oh, okay.
What a larger canoe.
Yeah, they had a special burial.
See?
They could have several wives.
Wait, what?
Yeah, yeah.
That's
They can
disgusting.
They had
even
a
sign
special
them.
seat.
And they had a special seat. They sat on a throne called the what?
Boo, boo,
The
boo, 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 boo.
Okay, so that's about it for the cacique. So they had responsibilities, sharing land, um, deciding on war and peace, deciding on fixed days of worship. But in return, they had different privileges. Now, my question is, would you like to be a cacique, or just an ordinary Lucayan, or just a noble or a priest? Which one would you rather be in the society?
Can you repeat that?
Like, if you was in a Lucayan society, which one you rather be? The cacique, the
The
noble,
cacique.
the
Cacique.
you want to be the cacique?
Cacique or noble or noble.
You don't want to be no ordinary
No, no.
Lucayan?
I want beagles.
Okay, you're gonna be on the big house. Oh boy, y'all. Anyway, let me not say that. Okay, so that means you're gonna have several wives too then. Um,
I don't have to.
okay, all right. Okay then. So yeah, the cacique,
You said,
but the
you
cacique
said
had
it
different.
cold.
The cacique had different responsibilities. So not only did they have the perks, but they also had the responsibility as well. So it's better than mine. Okay. So with that being said, that brings us to the end of social studies, not the end of the class, but the end of social studies. We're gonna deal with the next topic in arcade.
I want to be a regular Italian.
You wanna be a regular guy? I
Yeah.
with you, no stress. All right. Okay, so all right, so the last thing we was talking about how Jesus had to, Joseph had to run away from where he was to go where?
I don't know what you said just now.
Where we said that last time we met, we talked about how Joseph had to move from where he was, right? The angel that tell him, hey, move from where you was.
Yes.
Why? Why?
You say why?
Yeah, why?
Because the angel had told him that.
Mm-hmm.
All right, I can't tell him to be quiet about it.
The angel that tell them that what?
That King Harry wanted to kill baby Jesus.
Yeah, that King Herod wanted to kill baby Jesus. And King Herod was serious. How do we know that King Herod was very serious about what he's doing? What did he end up doing? Or commanding? Tell us.
Killing all the little boys under 2.
Yes, kill all the young boys under 2. And but by that time Jesus already had left, and soon thereafter, after everything died down and Herod had died, the angel told Joseph that, hey, you can come back now because the person who was seeking for the life of Jesus is now dead. And then we talk about how Jesus he grew up in which place? What's the name of his place that he grew up in? Where did he grow up in? As it was prophesied. Remember we talk about this? He grew up well. No one knows?
Nazareth.
Nazareth. Very good, Nazareth. So now we're going to talk about the boy Jesus. And we're going to talk about what happened to him when it was time for him to be circumcised, when it's time for him to be named. And so we're going to talk about that. So let's discuss that. So the topic for today is, so let me put it. So it's still Tuesday. Sorry, Thursday. My bad. It's Thursday, the 10th of February.
So we're talking about boy Jesus.
No, but that's not the topic. The topic is Jesus presented in the temple. Okay.
Okay.
So Jesus presented in the temple. So we're going to read Luke chapter, so the Bible verses, scripture reference. It's going to be taken from Luke chapter 2, verses 21 to 52. So that's the scripture reference. So let's turn now. Luke chapter 21.
We gonna read it?
Yeah, we're going to read it. Luke chapter 21. '21, 50. Yeah, 21, 50. Chapter 2, 21 to 52. So let's turn there. Okay, any readers, volunteers to read?
Me.
Miss Cooper? Anyone else? Volunteers to read? No one else? Miss Kennedy?
Okay.
Definitely. Alright, so I want you to read Miss Cooper 21 and 22, and then Kennedy 23 and 24, and stop right there.
Begin.
Yeah, go ahead, begin.
And when 8 days were accomplished for the criticism of the child, his name was Jesus, which was so named of the angel before he was conceived in the womb. And when the days of her purification according to the law of Moses were accomplished, they brought him to Jerusalem to present him to the Lord.
Go ahead, Miss Kennedy.
Wait, can you put the mouse where we at? I can't.
Say it again.
23.
Can you point your mouse where we at? Okay. And when the
23.
days of her
No,
purification are
no. We on 23.
23, as is it written in the law of the Lord, every male in openeth the womb shall be called holy to the Lord, and to offer a sacrifice according to that which is said of the Lord, a pair of turtle doves or two young pigeons. And behold, there
Okay, stop
was
right down.
oh,
So here's the scenery. Um, we know Jesus was born, and then after a certain period, we know that the babies were they have to be circumcised. Especially the baby the males, they would be circumcised. That's like a covenant that God made with Abraham, and every male Jew have to be circumcised. Okay, so after 8 days, let's write down. So after 8 days, Jesus, after the 8 days from his birth, Jesus was circumcised and he was named. Okay, so 8 days. That's when his parents took him to be circumcised and named. Now, um, there's another ritual. It's called the Purification Ceremony that the Jews take place. This happens every time a woman has a child. So she can go to church during the time of purification. Okay? If it's a boy, she would have to stay 40 days before she go to church. If it's a girl, she would have to stay 80 days before she go to church. Okay? So that's what we mean by purification. So she would stay in
Oh,
one
she couldn't
place.
go for 4 days?
No, she couldn't go to church. I don't know if she could go anywhere else, but she definitely couldn't go to
For
church.
40 days or 80?
40 days if it's a boy,
Okay.
80 days if it's a girl.
Okay.
And so now when her purification days is finished, then she was able to go with Jesus to church. So, and when her days of purification according to the law of Moses were accomplished, they brought him to Jerusalem to present him to the Lord. So the first time they brought him was to be circumcised and named. The second time they brought him was to present him before the Lord. That is dedication. Anyone ever been to baby dedication before?
Christening?
Yeah, Chris.
Yeah. So,
Anyone else?
I stand in for my friend, baby.
I did.
Okay, good. So, how are the people usually dressed?
color coded kind of.
Yeah, they usually color coordinated. They usually try to match. Everybody try to wear the same thing and try to make
And
it
the
nice for
baby
the baby.
dressed in white.
And the baby
Yeah.
dressed in white sometimes. So,
Most I see in white.
the idea is that you want to present the baby to the Lord. Okay, this is not baptism, but you just basically saying, okay, God, I thank you for giving me this child. I don't know what to do with this child, and so I give you back the life of the child so that you can help me to grow the child in the right way. And so that's what they mean by presenting him to the Lord, dedicating his life to God. Um, okay, and so they had to offer a certain sacrifice. If they could not afford what the rich people could afford, they had to offer um the simple version. So the simple version that Mary and Joseph um took was the pair of turtle doves or two young pigeons. So that's the poor version. They took this one because they couldn't afford the more expensive version. Okay, so number 25. And behold, there was a man in Jerusalem whose name was Simeon, and the same man was just and devout, and waiting for the consolation of Israel, and the Holy Ghost was upon him. And when it was revealed unto him by the Holy Ghost that he should not see death before he had seen the Lord's Christ. Anyone else? Number 27 and 28.
I can read it.
Okay, go ahead.
And he came by the Spirit into the temple. And when the parents brought in the child Jesus to do for him after the custom of the law, then looked he him up in the arms and blessed God and said, read the rest? Oh, just that.
Okay, good. So, where you left off, number 1.
I stop at and said, you on 29.
Okay. He said, Lord, now lettest thy servant depart in peace according to thy word. For my eyes have seen thy salvation, which thou hast prepared before the face of all people, a light to lighten the Gentiles and the glory of thy people Israel. And Joseph and his mother marveled at those things which were spoken of him. And Simeon blessed them and said unto Mary, his mother, behold, this child is set for the rising and falling of many in Israel, and for a sign which shall be spoken against. Yea, a sword shall pass through thine own soul also, that the thoughts of many hearts may be revealed. So let's focus on the first visitor, Simeon. So Simeon was any information, facts about Simeon in the story you could tell me already. Simeon was.
He was a prophet.
Yeah, he was a prophet. He was the angel of the Lord gave him a promise. What was that promise?
That he
That
wouldn't.
before he died, he will see the Lord Christ.
Very good. So that was the promise that was given to him, that he would not die until he see the Messiah. And sure enough, he saw the Messiah.
Yeah.
Now, when he saw Jesus, even though the priest didn't really pay much attention to Christ, the priest was just like, okay, this is a regular, baby. We don't care. But when the priest saw him, when Zacharias saw him, Zachariah was very, very happy. And Simeon, Simeon was very, very happy. And Simeon was so happy that Simeon started to sing praises to God. And he said, Lord, now I could die peacefully because you have fulfilled what you said you was going to do. Um, you have allowed me to see the Christ before I die. Okay. So he started to speak to Mary and encourage her, and he started to speak, and he was really happy that he was nearly finished. So he was very happy that he had seen Christ, and that you know now he can die because he's like, I already saw Christ, and just like how the angel told me that I won't see death until I see Christ. So there was another person by the name of Anna. Can someone read 36 and 37?
And there was one Anna, a prophetess, the daughter of Phanuel
Yes.
of the tribe of Asher. She was of a great age and had lived with an husband 7 years from her virginity. And she was a widow of about fourscore and 4 years, which departed not from the temple, but served God with fastings and prayers night and day.
Okay, good. So this is another lady. Any facts about Anna?
She's a prophetess, a prophet.
Okay, so she's a prophetess. Um, she was. There's a something terrible happened to her. What happened to her?
Her husband died.
Yes, her husband died, and so she was left in the temple basically all day and all night. Um, and so she saw Jesus. Oh, by the way, how old was she?
You can say a great age.
A great age. How old is she specifically?
I want to say in the 80s.
Four score. A score is 20. So four score is gonna be what?
60.
24? 20.
Four score. A score is 20. So four score is gonna be what?
60.
No, a score is
Or
20.
80.
40?
80.
80?
Yeah, a score is 20. So four score is gonna be 4 times 20, which is what? 4 4 score. 4 is 20. So four score is gonna be 4 times 20, which is what?
80?
80.
80.
So she was four score and 4. What does that mean? Four score and 4?
84.
84.
Very good. 84. So she was very devout. She stayed in the temple and all she did was pray and fast day and night. Very devoted person. And then so she in the temple, she is a bystander passing through. And this is verse 38. And she come in that instant, gave thanks likewise unto the Lord, and spake of him to all that look for the redemption in Jerusalem. So she was also excited, and she also started to sing praises to God for what he has done. So two persons met Mary and Joseph at the presentation of the temple. What are those two persons?
Simeon and Anna.
Simeon and Anna. Okay. All right, good. So let's get some notes in. Here we go.
You know, that took a while.
Yeah, the explanation did take a while. I just wanted you to get a.
So both Simeon and Anna was prophets.
Yeah, you could say that. But Anna was specifically called a prophetess. So
Is that a female version of a prophet, like
yeah,
prophetess?
yeah, definitely. So the name of Simeon's song of praise is Nuk Timotus. That's Simeon's song of praise. Now, when is Jesus named? He is named on the 8th day. So when Jesus was 8 days old, his parents circumcised. Spell circumcised wrong. His parents circumcised and named him. Okay, what else happened? So Jesus is presented in the temple.
Mary was cleansed.
Okay, so when Jesus was 40 days old, his parents went to Jerusalem so that what? Mary could, remember Mary Purification Ceremony has already ended. So you wanna, so they went there so Mary could
Eve.
perform the ceremony of purification. So what else? So Joseph and Mary Joseph and Mary uh they went to the temple so that Joseph and Mary could dedicate Jesus to God.
Mess with the sea and dedicate.
Yeah. Today, babies are what?
What you said?
Today, babies are what?
Christian.
Yeah. Babies are either Christian or what?
I don't know about
Or
that.
baptized. Okay. So while in the temple, Jesus and his parents so while in the temple, Jesus and his parents met Simeon. They met Simeon and who?
Anna.
Yeah. So let's talk a little bit about Simeon.
He's the one that God told that he would meet Jesus before he died.
Yeah, definitely. So the Holy Spirit so the Holy Spirit promised him that he would not die until he saw the Messiah. When Simeon saw Jesus, when Simeon saw Jesus, he what? What did he do? He blessed.
He blessed Mary and Joseph.
He blessed them and sang. And sang a song of praise. And sang a song of praise to God. And of course, we're gonna discuss the song at another time. But the next person was Anna. Now she was a widow. She was a widow. What does it mean to be a widow?
Means your husband passed away.
Yeah, means her husband passed away. Now she been a widow for a pretty long time. Very, very long time. She was also
A prophet.
84.
Oh, you mean age, my bad.
A prophetess. I think he was 84.
She's also sorry.
You put 80 hour.
Sorry, she's also an 84-year-old. She's also an 84-year-old prophetess.
Prophetess.
A prophetess.
Wasn't there a song that the priest sang?
Say it again.
Prophet sang when he saw baby Jesus?
No, Demetrius.
Yeah, the name of the song is
Nocturne.
No, Demetrius. No.
That's a Simeon song of praise.
So Anna.
So a prophetess is a woman.
So Anna didn't sing anything.
No, none that we know of. Who delivers messages? So a prophetess is the woman who delivers messages. About what God will do in the future. Okay, so that's it. We're gonna talk about Anna and the guy. We can wrap it up next week, hopefully. Okay, so that's just a basic overview on the cacique and his responsibility, and also on Jesus presented in the temple, the story and the things that happened therein. So with that in mind, we're gonna call it a night. And so I'm definitely happy that each and every one of you made it. You are the true survivors plowing through 8 hours. Sorry, 3 hours. So thank you so much, and I'll see you on tomorrow. Take care. Happy studying. Sorry, not tomorrow. Monday. Monday at 6 p.m. Monday at 6 p.m. All right?
See you later, Mr. T.
Have a good one. Take care.
Bye. Good night.
Good night.
Miss Vijay.
Yes?